All right, I am recording our conversation now. Welcome back, Alexandre, and thanks for jumping on to the hacking hours again. I don't think there's any big plans today apart from just moving forward on some of the issues. So one thing that we have been discussing offline is a bit about the API for Faery, because I think there are some uh, diverging ideas. And one thing you wrote me is the library GStreamer, which is I think is a very popular library to stream from A to B. That uses a very nice API. Especially if you want to construct very complicated pipelines. And so what I'm curious maybe just to talk about now is like what should be the scope for the CLI? Because I also see like two conflicting considerations in principle. Like if you want very complex pipelines, isn't it just easier to do that in Python compared to writing CLI scripts? I mean, where should we have complete feature parity between those two things? What are your thoughts?
Yeah, that's a very good question. And I should mention that I actually had a brief discussion about this with Greg
Awesome.
Orleans, when I visited him in Paris a couple of weeks ago, just touching base on the progress that had been done on Faery. So I kind of like to think of those things in terms of, in the popular term is user stories, but just sort of what would a user be trying to achieve where the command line would be a natural solution, perhaps the most convenient solution. So here I'm going to disregard users that just want, so we've got full of users that just like the command line as a way to perform simple operations.
Yeah.
So I've got this one event file, it's an ADAT, and I want to turn that into something compatible with the prophecy software, say a .row file, for instance. Something like that. I may want one very simple command. Perhaps I have just the one file. So I just really want to go Faery input output, and it just does the conversion, and that's it, and I'm done. But something like that, it feels more natural, I think, to use the terminal rather than a Python script. With a Python script, I'll have to figure out environments, set up my VS Code. There's a bit of a head, especially if I'm not familiar with Python, right? It's common, but you could absolutely find someone who's like, oh yeah, I was told just copy paste this command and run it, and that's it, and you have to think too much.
Indeed.
So that's one family of users. Those users could feasibly build on top of that interface. So say they have a directory and they want to convert all those recordings to something else. They happen to be familiar with, say, Bash programming, for instance. They could build the for loop in Bash and invoke the program multiple times to do all the conversions.
Yeah.
Sorry, what was it? Okay, so that's the simple case. Okay, so for those users,
one
ideally,
use case, exactly.
we want to make sure that Faery can be installed without virtual environments. That is, if you use it the way you'd use a simple Unix command, you don't necessarily want to have to set up an entire structure around it. That's kind of the whole point. It's always there. It's just command. Fortunately for that, we have PipX. I don't know if you're familiar with it, if you've used it before.
Very loosely, but essentially like it's a pip extension thing, right?
Yes. So you could feasibly, because we've created like an __ main and all sorts of wonderful little things in the Faery repository, if you have Faery installed in a local virtual environment, you can actually use it from the command line. But it means that every time you want to use it, you have to enable the right virtual environment, which, depending on how you deal with your virtual environments, can be a bit of a mess and so on.
Yeah, so it's just a virtualization, essentially. I mean, we also have Nix scripts, so this also works for NixOS, just saying.
That is very true, yes.
But I guess the concept is then you have an isolated version. But how does that relate to the API, then?
So that's the tricky bit. So if you install it with PipX, Faery as a Python package is installed somewhere in your system, but the idea is that it's installed only for the executable in that context. So if you do want to move to the API, write Python script, then you'll have to create a virtual environment or install it globally. But with recent Python versions, that's actually disabled on a lot of systems. At least it's the case on macOS. Nowadays, if you set a Python with Homebrew and pip install, it will tell you you cannot pip install globally. You have to create a virtual environment first and then pip install.
That's
which is arguably
crazy.
A good thing.
I mean, somehow, right? If this works for a CLI application, somehow Faery must be in the path, right? Otherwise, it wouldn't.
Oh yes. So for PiPx, so for virtual environments, the path is dynamically extended for whatever the virtual environment specifies.
Right. Yeah.
But that's only true after you enable it. For PipX, you actually need to modify your .zsh or .bashrc or whatever name the configuration terminal has to add the directory that PipX uses to store its binaries. So in this regard, it behaves like a standalone, separated apt-get or pip install or nix. Not sure what the command is, but lets you install Python-based executables system-wide if you set it up properly. So I think that that's a good thing to recommend because it's going to behave somewhat uniformly across operating systems.
I see. Yeah.
Anyway, so the point is, if you're going down that route, we can have a whole cohort of users that don't know what Python is and have never actually installed Faery as a Python thing. It's just pipx install, and then you use Faery only from the command line.
I see your point. So here, this speaks in the favor of having like feature parity because people might only want to use the command line. I mean, so coming back to the use case, I like the user story notion because then we can kind of isolate or maybe even prioritize what I think. Because obviously, at some point, we want Faery to take over the world and be like the ubiquitous operating system. I'm only slightly kidding, but in that case, in the use cases. I mean, you mentioned this very quick thing, like the ability to quickly go from A to B, right? But then, of course, there might also be these more scriptable things, like you said, like you have an entire directory. You might even want to have a file and then output that in multiple different forms. So more complex tasks like this, right? And then, of course, like you do even have the expert user who might want to also work with like their own filters or processes or something like this, right? So I guess I'm trying to get an understanding of which tool might be most appropriate. I think if you want to write your own filter, Bash is kind of out of the question, right? It doesn't make any sense to embed Python lambdas or something into Bash. We would probably want to avoid that.
We have managed to get my Discord stuck by trying to share my screen.
Uh-oh.
I am going to restart Discord. Be back in a second.
Amazing. And yeah, I wish I had like great jokes I could just like tell people. I don't really. But I can tell you that I made this nice issue here. So what I'm trying to do is to collate all the issues so everyone can kind of follow what happens. And in the coding repository here, like there's a list of open issues, so issues that are relevant for different libraries here, but also keeping track of all the issues that we close so we can get a tangible result of our work here. Hello, Alexandre, are you back?
Sorry about that.
No worries.
What happened? I think that Discord doesn't like my setup for some reason.
Rude.
Great. Okay, so I was about to like doodle a bullet point list of those user categories, but I'm gonna just try to keep it short, and that should hopefully be consistent.
Hey, I actually just opened an issue on this. Maybe I can doodle it there.
Oh, That's awesome. I can.
So we have the simple user, or like the command line.
Pure command line user trying to do something simple and typically, in my mind, very file based. So they're trying to go from one format to another, or they're perhaps trying to go from events to a video.
Yeah.
Which are two fairly common uses. And from my perspective, that user isn't really trying to use Faery to build an algorithm. It's really just using its capabilities as a file converter.
Yeah. Yeah. I mean, what about like streaming, like opening a camera and sending outputs over UDP?
Yes. So to me, that's also a valid use of the command line, but I would say slightly different kind of user. In particular, because for the first kind of user, I absolutely see that as being run on their own laptop. That's part of their post-processing of files. For the second kind of user, if they're streaming over UDP, for instance, they might be on a Raspberry Pi, they might be on a headless system. The headless part could apply to the first one, but to me that adds potential restrictions as to what we can afford to do and not do.
But why is that important? Because in principle, like, if the user asks for it, we're going to give it to the user. So if the user doesn't have the right resources or necessary processing to deal with that, then I guess.
Absolutely. More thinking along the lines of. Actually, it doesn't matter much. I'm picturing what I would call reasonable users, as in. But the whole point of a tool is that people use it in ways that you didn't expect. So I'm sure that at some point someone will want to do all the post-processing on a Raspberry Pi headless. It'll be great that even conversion can work just from the command line.
But I guess there is one distinction between using the tool in a finite sense, right? You have a finite file that goes to a finite file versus an online or streaming sense, because and that's maybe also the same distinction between standard input and standard out, right? Because if you say, give me a file, you know exactly where the beginning and ending is, which might lead to some optimizations.
That is true. And it is true that under the hood, we are readily representing those two things with two different types in the library. Got finite streams and potentially infinite streams.
But then again, I might also want to. We've done that several times, like taking a finite stream and streaming into UDP, for instance.
Mm-hmm.
That's still something you might want to do. This is hard.
Absolutely. So I'm not putting any restrictions in terms of use cases here. I'm just sort of highlighting that even though we're talking about the scenarios in very generic terms, I'm also trying to give them a very sort of down-to-earth flavor in terms of. Like if we have de facto something that is more general than the use cases we're thinking of, that's great.
No, but maybe we should just not. Probably overcomplicating it. Maybe it's easy to just state the use cases and then see where we go from there, right? So one thing would be like you said, something very file-based, like converting files or rendering files, right? Could be but also streaming. So it could be from file to use to UDP, or it could be from camera to.
If we think in terms of analogs, as in existing tools, typically for frame-based videos, that would cover some of those use cases. To me, the first bullet point is FFmpeg or ImageMagick.
Yes.
That's typically how the sort of command line tool that does that quite well for files. And the second, to me, would be GStreamer.
Yeah, agreed. And then maybe should we mention like the complex where you might want to write your custom filter or something?
Yes, I see quite a lot of overlap with the second bullet point for actually not quite. So for the second bullet point, the GStreamer-like thing,
Mhm.
to me, there's a very strong overlap between that and being able to pipe in and out of standard input, standard output. Because if you're streaming and you have real-time needs, you might be tempted to say, encode the video stream on the fly with a different video compressor, make it perhaps compatible with RDP and stream that directly to a web browser. That sort of stuff. Where whilst I do want to have a video compression algorithm built into Faery for simple cases where you just want to generate an MP4 video, I think that we shouldn't try to just have all the video formats and support
That would be
real-time
insane.
streaming and all that. But if we make sure that we can output a stream of uncompressed files to standard input, you can pipe that directly into GStreamer or FFmpeg.
I like that a lot.
And
I mean, this is the Unix philosophy, right?
you.
Sorry for interrupting. Yeah.
No, that's all.
But how does that relate then to the
yeah.
custom filtering? Because I mean, so just to spell this out, right? I guess one example would be that you have your own event flow detector, whatever. That you have some kind of lambda function that you need to apply to every event coming in, right?
So I'm thinking that, say, if you're okay, let's look at two distinct scenarios. So there's a scenario where you're just building a remote visualization platform. So really all you're doing is putting a camera on the Raspberry Pi, the whole thing in a box, powered with a battery.
Yeah.
And you're recording, say, Lightning, for instance.
Yeah. Good example.
So if you're doing something like that, really you're just streaming for the sake of having a visual, make sure that the thing is working, perhaps tune the biases from a distance.
Yeah.
So you probably don't really need to do any sort of processing. But you may want to have something that, say, drops events or frames if you're running late. Because really you don't really care about, like, what you're streaming isn't going to be what you save. Probably saving your events locally as well. And you're just streaming those frames to get a view of what's going on.
Yeah.
So in that scenario, you can absolutely, you could have an extra filter that monitors the input rate from the camera. So that's something that we don't have at all in Faery. So that's almost a completely other discussion. But imagine that at some point we have some sort of filter that monitors back pressure.
Yeah.
And says, well, we have a lot of packets waiting. I'm going to start dropping things randomly.
That is a very reasonable thing to expect. Yeah.
So in that scenario, for that user, it would be very tempting to have just a command line where they say, read from this camera, pipe into the filter that drops things when there's too much of it, and then push the output to std out, and then I'm going to pipe that in the sense of Unix to FFmpeg, and FFmpeg is going to compress that to get like a proper streaming video streaming format going on, and it's going to go straight to the browser of my user on a different machine. Then we have a slightly different.
Can I ask one question for this use case? Because I mean, whenever you say tune biases, then we are talking about more than just streaming images, right? We need some kind of feedback.
Right.
So maybe this for now we can just be like you want to simply just check that a visualization is working. Would that be fair? Because that's where you don't care about the quality of the video. You just want some video output, and then that's fine.
Yeah. Absolutely. To me, there's also that would arguably not be the role of Faery. If Faery is getting its events from a camera with something like neuromorphic drivers or prophecies drivers or something like that, it's the first sort of filter of that long chain. It would arguably be the role of that filter to expose endpoints to change parameters. Otherwise, Faery would need to know that streams have different endpoints, and we're adding quite a lot of complexity that is only relevant to cameras.
That's going to be tough. Yeah, I see.
Which we could do, but we could also just say, let's throw out that library to say start in, I don't know, WebRTC, WebSocket mode, where that thing actually spawns a WebSocket, and if you send instructions to that WebSocket, you change the parameter to the camera. And like that way, that can be still started by Faery. So Faery is still in charge of spawning that little module, but Faery doesn't have to know or understand anything about biases.
Yeah, I think I think you're right. I think maybe it might be slightly out of scope.
It is. So
I mean, it'd be interesting to do, right? Don't get me wrong, but I wonder whether we can simplify it.
If we take the analogy of GStreamer once again, Linux has something called Video for Linux, V4L, which you may have seen somewhere in your system.
Good question.
Yeah, that's the thing. So this is one of the... So GStreamer has a concept of sinks and sources, or drains, sources and sinks, something like that. So a little like Faery, it can take different inputs. There can be a camera, there can be a file, and so on. One of those inputs is Video for Linux. So any camera, any USB camera, webcam, and so on, plugged into your system can be used as your source of images. However, those different cameras can have different parameters and so on. That's hidden by V4L. So V4L also lets you talk to the camera to change, say, the exposure. But GStreamer doesn't have to know about that.
Yeah,
it's kind of you've got this sort of sideway route to control the camera proper. And I'm sure they can access some of that through GStreamer, but it's not built into it as a sort of essential.
It's an interesting idea, right? I think this would be also great to have. I mean, again, coming back to the Unix philosophy, I don't think Faery should solve all the video streaming needs. We should just be able to provide some format which is supported by other tools that then does a much better job than we probably could. So something like streaming this to V4L and then figuring out what to do afterwards is a great idea.
Absolutely.
But so you had a second user story, right? Because now we've talked about just like having a visualization.
Yes. So the second user story would be for someone also building a real-time platform. This time they're actually doing some processing of the data. So let's say that they are interested in, say, GPU processing of event slices. And let's pretend, for instance, that they are using AStream to do that part of the processing.
Yeah.
And for some reason, for their particular use case, it's easier to use Faery as a front end. So really what they want to do is read data from a camera in real time, do some denoising, but they don't want to do denoising of the frames. They want to use a rich event stream to denoise at that stage before the events have been together. And maybe do some more magic on the events. And when they're done, they want to stream the resulting frames straight to AStream, which can then have fun with them through a GPU pipeline or something.
Yeah.
For a user like that, they would want to potentially also use the command line to easily pipe together those very Unixy tools. But they would want to perform some actions, in this case, denoising, before they push it to the next thing. There could also be some cropping. Perhaps they want to use the center of mass of recent events and build a region of interest around a tiny slice.
Yeah. And
stream relatively small frames, perhaps 128 by 128, but at 10,000 frames per second to the GPU part of their pipeline, something like that.
Yeah. And yeah, I see. I mean, I see your point that would be nice to do in the CLI, because then you can just you can just pipe this as a normal program, right?
So that's where there's a very important question to ask, which is, can we cover those use cases without a CLI?
Immediately, I think so, yes, because in principle, you can write all of this in Python. You could just have a Python script, right, that says, so let's ignore the A stream. This says you open the camera in Faery, like, and then you do some filter denoising, whatever you need to do, and then you output them. And then let's just assume that Faery can do GPU frames, which is a different feature request. But in principle, you can do that in Faery, right? And then
part of the reason why I've been talking quite a lot about piping through Unix pipes is because I've actually implemented exactly that sort of pipeline with FFmpeg for streaming. And well, that's actually how CarryDotilla, which is one of the sort of precursors to Faery, under the hood, CarryDotilla uses FFmpeg. It's a bit of a nightmare because on Windows you have to install it in a very specific way and so on. But really, CarryDotilla does the piping. And it's tricky and fiddly because you have to pipe in Python. Right? You only have one script. So you have your script that, in the case of Faery, builds the Faery pipeline. But the same script also has to create a sub-process for your FFmpeg instance. And you can't use the easy high-level tools that has to be relatively low-level because you want those two things to happen in parallel.
But couldn't you imagine just streaming your frames to standard out? It's similar to the V4L thing.
Oh, I see what you mean. So so you invoke a script and then you pipe the output of that script.
So the script itself would just dump to standard out. I think it might not be a very efficient thing to do with frames, but in principle it should be feasible. The question is whether FFmpeg supports that. I don't know.
I think so. So where it gets a little tricky is that any debugging statement you'd use, say print, would effectively be sent from your script straight to FFmpeg. So that makes your debugging experience quite challenging. And if you don't pipe immediately to FFmpeg, you will still see your binary frames. So your print statements will be mixed in with the binary data.
It's not wrong. But so I think part of my questions here is also relates to where can we cut the cake so that it works quickly now, or we can do something that works quickly now, but with the ability to extend. Because what I'm hearing you say here is that you might want to, in the command line, provide some means. And let's just figure out later what that means. But some means to work with the events in a custom way, right? So that could be doing some noising or whatever else, denoising. But my point is that I wonder whether we can maybe reasonably ignore these more complex use cases and then still maybe suggest to implement that later. Does that make sense?
It absolutely does. I should mention that the thing that I implemented does work. It's already building those complicated pipelines. So
that's very cool.
I think that it is feasible.
It's doable.
Is my point. Yeah. So I'm sure they'll bring more problems down the line, things, edge cases and so on. So it's still a reasonable question to ask: do we want to do this? But yeah, to me, it really boils down to the fact that if you want to do some pre-processing, whatever that is, with Faery, but with the idea that you're going to pipe the output to FFmpeg, being able to do that purely from the command line is pretty neat. Not
that is very true.
That's the only way to do it, but it's kind of a natural way, or to me, it's one of the scenarios where I could reasonably see myself, despite knowing both Python and the command line, say, okay, here, the command line is actually easier. This is the easiest way to get to what I want to do. And for me, a lot of the scenarios that involve the command line, essentially half of it, right? Anything that has to do with streaming real-time processing, basically, as soon as it's not from file to file, I see piping as quite an important part of those features. To me, that's really typically the cases where you would want to be able to pipe.
Yeah. But where does that? So, in principle, I think I agree. But where does it leave us? I mean, coming back to the user stories, maybe are there more we want to add before we then discuss practicalities in terms of implementation? Like, is this?
So yes, there is a fourth one, which is the also coming from Carry.li in terms of use cases.
Mm-hmm.
It's typically what my lab does a lot. You record short event recordings, 10 to 30 seconds, and quite a lot of them, because we do quite a lot of applied work on just recording drills, lightning strikes, sports, planes,
sorts of stuff.
satellites,
yeah.
All sorts of stuff. So what you end up with after your outdoors data collection session is perhaps 20, 30 recordings. And you quickly want to get a sense of what's in them, render them. And more often than not, then you want to slow down very particular parts of those recordings, because quite often we are interested in very fast things. If you have 30 seconds of recordings, but the thing that was interesting, say the bird flying through your field of view at high speeds, is only visible for a second. So in this scenario, what you want to do is render all your videos once, get a sense of what parts of those videos would be useful, and then narrow them down and re-render that in slow motion. That's a workflow that is very similar to the sort of workflow you'd have if you've ever done some video editing, where you've recorded an event, your family on holidays, and you're putting together like 2-3 minutes of video with music, something like that.
Yeah.
So you have hours of recordings, and you need to quickly find the good parts and assemble that.
But then, I mean, do these control then is something you give in advance? So when let's say you have your 20, 30 videos, and you identified quote unquote interesting regions of them, would you then say, okay, give me all these videos and then specify the region and the speed, or would you then do that? Would you rather just open up a video viewer for each recording and then manually seek, or what are you thinking?
No, so typically it's a very iterative process. So you do a first pass where you render the videos. So you have real-time videos at first, 20, 30 seconds. Then open them with whatever your favorite video player is. Quickly look through those videos to find those parts of interest.
And you would write that down in text somewhere, or?
And you write that down in text. So typically what happens with Carry.li, which turned out to work quite well, is when you get your directory of recordings, you run the command init, and that command will scan the directory in question, read the files to calculate the begin and end. So you have those markers in the configuration, and it generates a template configuration, which is really a set of instructions as to what to render. You then run Carry.li run, which will invoke all those commands and generate the videos in question. You watch your videos, find the parts that interest you, then go back to the configuration file that was generated and change, or rather add, more rendering tasks. So you copy paste the block that says render this video from begin to end, and just change the begin and end and the playback speed and so on. And then you run Carry.li again, and because Carry.li saves the videos alongside small files that keep track of what parameters were used, you can easily skip whatever has already been generated. So that way, the configuration file also acts as a history of all the things you've rendered. So you can easily go back and be like, oh, that file actually had 2 interesting slow motion bits.
Yeah.
You can render them twice.
But that would require, like, you need some way to generate a lot of these specifications, right? You have to somehow transform the handwritten notes into like very specific timestamps and control instructions.
Yeah. So the idea is that you don't really take handwritten notes; you actually directly modify the configuration. So as you're watching the video, like, okay, from 10.6 to 10.9, there's something interesting. You go back to the configuration where you copy paste one of the actions or tasks for the video in question, and then change those numbers. And feasibly, you can even run that immediately. And in the meantime, watch the next video. So you can sort of work in tandem with the computer whilst the computer is rendering that new little chunk. You can look at the next one to find more interesting things. That still requires a little bit of knowing the command line and so on, but that turned out to be fantastically useful. It's not as good as a proper GUI, but it's also way easier to build than a proper GUI.
Yes.
So 2 more things to add by CLI, which I would also love to port to Faery, ultimately. So one of them is the fact that CLI doesn't just generate videos. By default, it also gives you the event rate curve, what we call wiggle plots, which are just videos played back and forth quickly.
As a separate plot, so you're not embedding that into the video, you're rendering that separately. Yeah.
A different asset. You also have what we call color time plots, which is just the events, the timestamps represented with colors. So you get just one frame for the entire video. And if the video is short, you actually get quite a lovely image that encodes time in colors. Mostly looks pretty, but there are a handful of cases where that's actually useful. Pedestal also generates spectrograms. So if there's a beat, some sort of frequency clearly visible in your event-based video, the spectrogram will typically show a very strong line, strong response.
Yeah.
So all those things are not meant to be algorithms in and of themselves, but it's just to emphasize that event recordings are different, and that sometimes an operator that you would not think of being a good computer vision tool turns out to be very useful.
Yeah.
So it's also a way to throw all the information at the user, and the human brain is just fantastic at looking quickly through that and seeing patterns and be like, oh, wait a minute. There might be something to the event rate. It's very clearly doing something unique whenever there's something of interest.
This is kind of a diagnostics, right? So it's like when so here, for instance, let's say here, right? Okay, maybe that's a bad example. Here, for instance, when you want to stream data, like you don't care about anything but getting data from A to B, right? But this is more exploratory, right? So it's more almost like exploratory. Statistics.
So, for the sake of completeness, absolutely. I started playing with Faery as a follow-up to Kaidotella because one of the issues with this approach is, or at least the issue in Kaidotella, is that the script that was generated was Tamil, which is a markup language.
Yeah.
So it is not a scripting language. So as a result, the script was very static. So if you wanted to do something like, say, generate for one video the same color time plot, the same color image, but with different color schemes, you would have to do quite a lot of copy pasting. Because that was an issue, I then added templates, was sort of a way to express that you wanted to, very similar to the matrix system in GitHub Actions.
Yeah.
But if you have cross fields or if you want to ignore some of them, it quickly blows up in terms of complexity.
Yeah.
That's when I realized, wait a minute, this is a programming language. What I want is a for loop. This is why I'm struggling. And that's when I realized that actually having a Python script would be much better. What's interesting is that quite a lot of web libraries, for instance, have gone the other way around. They started with Python scripts and then moved to non-Python configurations. But that's mostly for security reasons, because typically those configurations are meant to be shared by users, and it's kind of bad to have to install library. Actually, it used to be the case in Python as well, right? Setup tools used to have Python scripts. Define the package.
Setup.py. That's true. Yeah.
which is
But-
great because it's super flexible. You can do all sorts of crazy things, but you
But-
can also do all sorts of crazy things.
Exactly. That's a really good point. Like, here's my library. By the way, run this arbitrary script. Yeah.
But in this case, it's not an issue because the user has chosen to trust us, and we're generating this script just for them. So
I
it's
feel
not
like
a script
that's like a
meant to be
famous
shared.
last word the user to. But I think you're right, and maybe it's also one of these things that might be a concern later. But I think for in the beginning at least would just be solved by, swallowing that camel, if that's an English expression, and just seeing. Like leveraging the Python API that we have at the moment, right? And then seeing whether there's better ways to do it down the line.
Exactly. So yeah, that I'm.
But I love these things. Like, I mean, this would be super helpful to have because I've done this myself, but in Matplotlib, right? Like looking at huge chunks of events and then having to do this.
So yeah, I'm quite. I placed that particular use case quite high on my personal wish list.
Agreed.
Because that's something that has proven to be useful to other users.
Oh, for sure.
I
agree.
I think that's a good picture of what we want the command line to provide.
I think it's very, very nice. I'm not sure we should solve all these problems at once, but I think they're going to serve for excellent issues down the line, right? Because you say, okay, now there's an issue of make sure you can support events time average color pictures, like you say. I think that would be really useful and probably quite fast if you do it well. But yeah, I mean, I wonder whether we can start discussing the CLI API. If you will allow me 1 minute, I need to get a bit of water. So I'll be back quickly. Be back.
I'm gonna go get a coffee in the meantime.
I guess Discord went down again. Welcome back, Alex. How's your Discord experience?
I'm trying something. macOS might be to blame. Yeah, I did all sorts of security features, and it could be that I was messing with Discord. Try to access my screen for recording. Arguably a good thing, but possibly what was crashing when I tried to share my window. Anyway, I don't need to do that right now, but
sorry about that.
no, that's all right. Okay, so shall we discuss the shape of the API?
Yes. I mean, does it make sense to talk a bit about it from a top-down level, or we start with thinking about what we would want to have, or what would be nice, like a nice suggestion or design decision? Because I mean, so the way I designed the A-Stream API is to write things out in clear text, and the reason for that, I think, is because I've had a lot of frustration trying to remember all the flags of all the different programs. And I mean, there are some conventions, but of course, like any good convention, they always break. So
That is true.
one reasoning has been that if I can just, if we can have, you know, humanly what I would expect to write. So the learning curve will be low, because in principle, if I know what I want, I can just specify it and write it out down in a way that's somewhat intuitive. I think that might help it a little bit. And maybe also another point I think is important to bring across is that I think you should have meaningful defaults. So we should ideally also write as little as possible for the most common use case.
Absolutely.
So I mean, one concrete example then towards that, which I'm curious to hear your opinion on, is that we would simply just have some notion of source and sink, essentially, and then all sorts of variations upon that. Right, so that if you, for instance, want to go from file to file, you specify, here's the file I use, and here's the file I want to write. And I mean, I've seen a few different conventions, right? I mean, I think if MPEG uses -I, so it'd be something like here. Pandoc is also I'm a huge fan of this. I think they just mentioned the file here, and then I use -O for output. A-Stream, as you know, uses this convention. And actually there are then different output types. So if you want to do this, you should write output to a file called a.dat for instance. Input from a file, and the same output file. And the reason here is that really disambiguates, so there's no this can't go wrong, right? Because you know that it's a file you send to. Alternatively, right, we could imagine something else where you would have, I guess we can do this, where you would have, I think you discussed it before, like something like a render task, which would then be all the rendering problems, right? Where you'd have some kind of file as an input here, and then output into, I should probably call this Y, something like this, right? Because then that would be, so this could be, let's say, IO modular, and this would be task modular, right? Because then of course you'd need render, or you need a convert function if you want to convert files, or you'd need inline, I think was another one of the example, where you then actually run the command line inline.
So the idea of inline was to cover anything that would be modular. I'm not sure that inline really conveys that.
No,
so arguably modular, but yeah, that's kind of its role. So that comes from the realization that, at least at the moment, Faery is a single pipeline. There's no splitting, no T-junctions.
Yeah.
Partly because we have a pool architecture. So you need a single thing at the end that pulls from the first one. Not to say that we're stuck with that overall architecture. There are ways around it.
Exactly.
But it's not that simple. So now,
in the command line, that's true, right? But in principle, in Python, you could do this, because the streams are exactly designed such that when you copy them, you get two data sources or data.
That is absolutely true. But it kind of starts from the beginning. So if you copy a stream, it's not like a T-junction. It looks like a T-junction in your Python code, but in terms of what actually runs, it's going to be the beginning. The first part is going to run twice.
Yes, for now. Yeah, that is true. That is true.
It's not that easy to work around, because if the two ends of your T-junction are not, the whole point would be for them to run in parallel.
Yeah.
Otherwise, you'd be buffering.
Oh yeah.
If you read them sequentially, you would need to buffer the entire file,
That would
which
be a
might be
mess.
gigantic. So that's not an option. And if they run in parallel but have vastly different computational needs, then the CPU is going to need, or the GPU is going to need to spend more time on one of them rather than the other. Suddenly, you need to bring in all sorts of concepts like back pressure and buffering and frame drops and so on and so forth. So by having a single pipeline, at least for the time being, we do restrict a little bit what the library can do, but we dramatically simplify its overall architecture.
Yeah, I agree.
There's a good side to it, which is that it's fairly easy to have a one-to-one mapping between what's possible in Python and what's possible on the command line. Hence this idea of, at least for now, having this, because we could almost write whatever we write in Python right in the command line. You would just use Python syntax to describe something that looks like your first line, right? We would need to add like a filter, as you said in your email earlier.
It kind of reminds me of, do you know the shell? I think it's called new shell or something, like a Rust shell. But the point there is that they work with objects, not binary streams. And I'm just mentioning that because I think I mean there are several concerns here, right? But I think one interesting thing is what the language here is trying to express. That's essentially what we're trying to define. Like, what is the semantics here? Like, so for instance, in the render, then the semantics revolve around the task, right? Now I want to use this thing for this specific thing, like rendering, for instance, which is something that we define. But there's another concept, like if you do the I/O modular, then it's the semantics revolve around the piping. So it's almost like a switchboard, right? You take a wire and then you wire it down here, or you can wire it somewhere else. And what you're suggesting there with the Python syntax, that's more of an object notation, right? So you can imagine something like you go Faery, whatever, open camera dot filter, and then you do all these things, right? Which is the Python syntax. Of course, I mean, we could be cheeky and then even just evaluate this as Python code, but I'm not sure that's going to be a great idea. Like we can do.
So the biggest challenge, though that's arguably at times a problem with the other options too, is that brackets and so on are not universally, but often recognized as special characters by Bash or ZSH and so on. The script gets isn't actually what you're writing, it's that, unless you put it in single quotes. But that's why I quite like your idea of going with pure text. Because, I mean, with as few special characters as possible, the IO-centric option, this means that users don't have to remember to put it in quotes. And that's a fairly simple rule, but if you're calling that from, say, another script, because you're iterating and so on, you enter the hell of quote escape in Bash.
That's not fun. But I mean, so there are two downsides here. I'm curious to mention, because you're right. This is easy to write out, but it is very verbose, right? You have to write a lot of characters, as opposed to this. Another problem I think we might face is that, like you talked about how it might be nice, for instance, like GStreamer, to provide like a series of piping, right? So we can say like time slice is like exclamation mark, I think is the syntax for GStreamer, right? Some denoising exclamation mark, and so the exclamation mark kind of fuses multiple filters. Although maybe that can be addressed, because here we can in principle just concatenate them like this, right?
True.
Yeah. Okay.
Yeah.
But what are your thoughts here?
So sort of where my intuition went, but then again, I'm happy to go with pure text instead, is let's call it iocentric this or iocentric 2, which is very similar except that input becomes optional. So it's like an ffmpeg minus I. So you can actually omit it. And if you do, by default, input is standard input.
Yeah.
Then instead of the keyword filter, exclamation mark.
Hello, Peter. Welcome.
Hello. How's it going?
We're just discussing Faery APIs.
Fantastic.
And I'm recording, by the way.
Don't let me interrupt. Keep going.
Okay, so this would be optional, which would default to standard input. Yeah.
Yeah, and thus with a minus or dash dash in front of input.
Like
Make it clear that this is yeah. Now, at least for me, that's kind of the de facto standard that I've integrated. I don't know if it's a good standard or if it's all that widespread, but if it's a positional mandatory argument, then you just write that argument. And if it's an option, then it has a minus sign in front of it. That indicates that the position is not relevant and that the value is optional as some sort of default. But that's by no means universal.
But something like this, yeah. And then instead of filter, you would call something else?
And then that would be exclamation mark as a shorthand for the keyword filter. The biggest benefit
and that would also be optional,
that
right?
They're not optional. They're mandatory, and they indicate that it's kind of it. So this is really directly, or it's optional in the sense that you don't have to use a filter if you don't want to.
Yeah.
But if you're using a filter, you have to use the exclamation mark. So this is directly taken from GStreamer. And the idea is that it looks a little bit like piping, but you don't want to Unix pipe here.
That's
right?
true.
It's
Yeah.
within the program, so
I
it's
like that.
kind of why they use that, I think. So the idea is that you're really piping the output of the previous filter into the next one and so on. The biggest benefit, I think, of using a character here rather than a word is that let's pretend, for instance, that time slice actually has mandatory arguments. You need to specify what you want to slice. That's the point of this filter.
Then you simply just grab everything that's up until that.
Until the next exclamation mark. So that way, if you forget an argument, instead of thinking that filter, the next filter keyword is actually the second parameter of that function, which means that you'll get a very confusing message that says that you've given too many arguments, because it's going to think that filter and the next one is also an argument, when really you don't have enough arguments, that sort of stuff. So having a distinct character makes it potentially easier to inform the user when they make a mistake.
I like that. I mean, but at some point, like, again, if you would then keep this notation, you do something like output here.
Yeah.
So that means,
and likewise,
if here, for instance, then you have some arguments here, then it's not going to be breaking on the exclamation mark, it's going to be breaking on a dash dash output.
That is true. So at least the way I implemented it, all the dash dash arguments are passed first by argparse, and thus sort of taken out of the thing. So what you give to your custom parser is everything that wasn't a flag in its value.
Yeah.
There are a few subtleties to that. But yeah, the idea is that whatever's left, you give to your algorithm. The downside is that, especially if using numbers and so on, Bash still tries to turn some of those numbers into expressions or things. So I had to put the whole thing in single quotes anyway. But I don't know if that's avoidable, or it could be that I just did something weird this one time. I don't know.
Well, so I remember one of the discussions we had at Telluride for this CLI stuff is that we did consider argparse to begin with, but there are a couple of problems with it. And one is that it doesn't really support recursive parsing as far as I remember. So for instance here, if you want to have an input, which is then also having a file, but also having a whatever else, right? Camera, something else. Then we run into trouble. And I think there are a few other things with argparse which seemed annoying. And I think my current intuition is that we can do something like this, but if we do, we would probably need to hand roll our own lexer, which is not that hard thing to do.
I'm a bit confused because I'm pretty sure I used the argparser in my PhD and I had to deal with like gazillion different NPZ files and JSONs and whatever. Isn't it possible for you to just set that particular item that you're trying to pass to argparser as a list? You have an nargs star or nargs plus for a particular parameter. So is that what you're looking for? Or?
But wouldn't that eat up everything from that argument? So if I say exclamation mark nargs, wouldn't that just take everything after that?
No, it would first pass the entire thing.
It grabs
wonderful.
everything for that argument. So you say, what do you have there? You have a dash dash output. You can say dash dash out if output was defined as having an args star or plus. Well, if it's plus, it's required and you need at least one. If it's star, it just takes whatever you have there. But if it's star, you could say file y, file z, file blah, and it would just take all of them. That one happens to be at the end, I think, of that one line. But even if you had something that said input afterwards, and input could also be a list, then everything would be parsed up to the next dash I or dash dash input or whatever.
That's amazing. Okay, I think I have to revisit argparser. Maybe because that would be the trivial solution, right?
So there is something that we may want to do that argparse doesn't do quite well, and it is positional options. So say if you have input, which can be a camera, which itself has a bunch of options, including output for some reason. Then in argparse, that minus output, even if it's right after a camera, would interfere with your very last dash dash output. Argparse doesn't have a concept of, I'm entering into a different thing and now I'm going to use a completely different set of rules.
Yeah, because that's the recursor part,
block.
right? You don't have like sub parsers essentially.
Yes. But
can you say that again, please? What is missing? Because argparser does have subgroups that have additional grouping capability, but maybe that's not what you're looking for.
It does, but with a keyword to define an action first. So, for instance, let's say that you have different filters with an optional width. So what you would want to, and let's pretend that we're using argparse not just to parse some options, but really to parse the whole thing, right? We're trying to build everything out of argparse for some reason, avoiding our own parser or lexer. So in that context, we would want to have Faery input a file, a first filter, say denoise, which is going to take this width parameter, so minus width, then another filter, say crop, and then we would give width again to that other filter. From the perspective of argparse, that would be twice the option dash dash width. It would not understand that those are options that belong to whatever keyword comes before them, something like that. I do find those a little confusing because you really have to keep track of where things are. This is what ffmpeg does, for instance. So depending on where you place size hints in your command, ffmpeg will assume that you're specifying the input or telling it what you want the output to be. But if we can avoid those edge cases, especially with the dash dash notation, that to me really means you can put that anywhere you want.
How
hence the idea
that you're going to reuse particular configurations?
Yeah, or just have a distinct notation for filters. So minus input or output, like anything that's global to the entire command is fine. But anything that has to do with a particular filter, say crop, and you want to specify width, height, X and Y, will not use a flag notation or something that argparse would understand. It'll just be nargs plus. And then we'll have a completely different chunk of code fully responsible for essentially parsing everything else to apply our own rules wherever position matters.
Or to use a file. Some sort of configuration file where you can describe it in text, in which case you just pass the configuration file as a configuration file to the run that you're trying to do, and be able to hopefully reuse your configuration based off of that. And then that
is a very good point.
It's reasonable. I feel it's reasonable to have a simplified interface, which is what it sounds like you can do with within the limitation of argparser. But if you want something more complex, yeah, you have the option of either extending argparser somehow to take in additional parameters, which it doesn't currently support. I don't even know if it's an open source project, if that's what something that they're looking for, or if it becomes too tedious to type everything in one command and copy pasting in a command line, then having a reusable file somewhere is probably also somewhat reasonable. A CFG file that says this is how I want these particular parameters to be set up, and it allows you a bit more flexibility to do the kind of stuff that you're saying. Then you can fiddle with some other parameters as you're typing in the command line. You're doing your magic at runtime, but still keeping the defaults, let's say, that are in some configuration file.
So two things on that. So to me, the appeal of argparse is mostly that it's part of the standard library in Python. This just also means that if we want to support older versions of Python, even if we manage to get changes into argparse, that would be for 3.14 at best in terms of Python releases, which means that we would still not have those features for older versions of Python, because you can't install argparse. It's part of your Python distribution. It's built in. You may be able to install a more recent version. Certain that it's built in. It's definitely part of the standard library. You might be able to upgrade it somehow, but I don't know how. So the other, regarding some sort of way of some sort of configuration, rather big question is that since we also have a Python API, do we want nonetheless some sort of yet another language that describes a pipeline? Or if you need a more advanced pipeline, then you should be using the Python API. Is there a use case where it will make sense to have a textual description loaded by Faery and its command line that essentially describes the pipeline in code, but not in Python code? I don't have an answer. I'm really wondering.
I think the configuration stuff isn't necessarily super custom. Like I remember Spinnaker has a CFG. Let me see if I can find it somewhere. There's some CFG files, some configuration files that dictate how you want to run. Too long ago.
You're getting old, Peter.
Relation, I think. But it's basically, there exists a Python package that knows already how to interpret configurations in a particular format. So if you can mold what you're trying to do with the inputs you're trying to give to your program into the format, if it's even compatible, I don't know, I don't remember those rules, then you wouldn't have to reinvent the wheel. It might even be we can have a look. I'm guessing this is what this session is for. What's this Python configuration?
Well, I think there's a value in a configuration language. I would probably argue in the beginning we just start with something simple as CLI. And some one discussion we had before you came is just to list out some of the user stories, like so what people might want to do with this stuff. And I think there's kind of a simple start where we just want to take a file, dump it to another file, open a camera, dump it to some output. And then when we get more complex pipelines, we might have to look into something else. There's also a separate argument, which I think is important, namely that you could do this in Python, right? So if you want to have very complex things, you might want to escape the CLI and just straight up write it in Python. I don't want to
I dropped a line to the definition of config parser. Maybe it's something that's useful. Yeah, but your logic is very good. Just get the user stories out there. How are you meant to? How do you want to use it? Where do you want to use it? What does it need to do? Prioritize them. Find which one is most germane
nice.
to what you want to do and to the community, and then focus on those features. Very product oriented.
Many years of hard PhD lessons, man. Because I think all of this is amazing to have down the line, right? But there are just some tasks that would be helpful to solve at the moment, right? And then we can see whether they're scalable. I mean, this seems good, right? Also from the point of view that you mentioned, Alex, which is to not have too many dependencies.
Yeah. So if we look at the I/O options in terms of structure, so to me there's value in having enough flexibility that you can essentially build whatever pipeline you want straight from the command line by just writing together, kind of like GStreamer, those filters.
Yeah.
But I also think that there are a few very specific pipelines, not all of them, that deserve a task-centric option. Tasks like converting or rendering, where to me those are likely to be so often useful that it'd be nice to have a shorthand for them, essentially.
I see. So when you say converting files, you mean, for instance, going from file X to file Y?
Yes, which, as you pointed out, like the input-output syntax isn't terribly complicated for that. So,
well, it is very verbose.
Well, I mean, you're just writing Faery input, name of the file, output, name of the other file. We could simplify it by one word by just saying Faery convert and then the two files. But that's barely simpler. So if it was just that, then I'd argue that sticking with something that's generic and works everywhere would have more value. I think that the case of render is more interesting, because render is quite an involved pipeline.
Because there's so many flags or
parameters and so on.
But
so if you just
this is rendering then to his file. You don't mean streaming it into a video protocol or something.
Yeah, I mean, take events, turn them into frames somehow, and then build an MP4 video out of those frames.
Yeah.
And when you do that, you quite often want to choose the beginning and end of where you're going to convert the events. You also want to choose the playback speed. Is it real time? Do you make a slow motion video, or do you make a time lapse where you're actually going faster than real time? What sort of colors do you use? Do you just bin the events, or do you build time surfaces? If you build time surfaces, what decay do you use, and so on and so forth? And all those can be expressed as a pipeline, but the options are not necessarily insanely obvious for someone not familiar with the intricacies of Faery. And that's where a render standalone task might prove.
But how would that be different from doing this, where you just simply say, okay, you're not outputting it to a file, you're now using our super advanced render, which is essentially just like file would then just be a subset of render in this case, where render then gives you like all these things.
Yeah, absolutely. So definitely possible. It basically, we have super filters on the command line that are filters that do not exist in the Python API, and actually combinations of multiple filters. So that does raise the question, if they are so useful from the command line, shouldn't we add them to the Python API, even if they are a combination of multiple filters?
So is that how it is right now?
So right now, I think that do you have the email that I sent you with an example?
Yes. 1 second. Because this sounds counterintuitive, right? I mean, my impression is that we should start with the Python and then go to the CLI. Although, I mean, maybe this is fine.
So one thing worth mentioning in the chunk of code that I wrote for the CLI is that when you're writing the filters, your script is getting strings of everything, right? Whether you write a number or text, Python sees it as text. So you have to decide what part you convert to an integer before passing it to the pipeline functions that expect integers.
Yeah.
And what do you convert to a string? If it's an enum, essentially, so a finite set of options, you also need to detect that the string isn't understood by your Python function and so on and so forth, ideally in a clean way. So I did that with annotations. So basically, the chunk of code absorbs the annotations.
Right. And
then decides how to pass what's coming from the command line based on the expected types. So if your second argument is supposed to be an integer and it's not, that function is going to try to convert it to an integer and then print an error message saying this little chunk of text here is supposed to be an integer, but passing it failed.
Oh God. I see. I mean, okay. I feel like
that's a feature that we will need to preserve, regardless the way we decide to write those pipelines. On the plus side, it also means that we can there's no extra work needed to add more filters to the command line. If you add them to the Python API, they are automatically read by that chunk of code and dynamically injected.
Yeah, I mean, we should also talk about that, because I remember before, like, we had this very nice object-based API, right? Where you have a stream, you would say, okay, then apply this, and then you would get an object that specifies then the configuration for an output, right? So there could be like a CSV output, and then that object itself would know what to do. But I think now it's changed, so it's let me just find.
It is still fairly similar.
No,
in
it
essence,
it is the same. Yeah, but my okay, that makes sense. Like, the reason I'm saying that, just in related to the API stuff here, right, is because if you can just tie this to object, I think that would be much easier, because then it's just a series of apply commands, right? Like we can say, if you say output MP4, then you have an output object with that configuration, which is, I think, similar to what you're saying, but maybe a bit dangerous in parsing, because you're constructing a configuration object, not necessarily entire Python code. Although maybe that's similar.
Yeah, Python's pretty good with, I think it's called reflexivity in programming languages, or reflection.
Yeah.
The ability to inspect its own code, and Python does that fairly well. I mean, it's a workaround to better features like proper templates or something like that. But also means that you can fairly easily convert from one way of looking at the problem to another at runtime dynamically.
Okay, but I wonder where that leaves us right now, because I can see your point. I mean, okay, maybe let's come back to the next step, right? Because I can see that it's nice to have a task centering here, but I think I'd like to understand exactly what's the difference from doing this down here, where you say, okay, now you render this, and then specifically as a possible target in the output, say, okay, here's render with all the features that follow that. Maybe verbosity, like we write less.
Now, so whilst I was sort of writing so if you go back to the Python API, since you're sharing your screen, do you mind opening VS Code?
No, for sure. I'm on the wrong branch. Let me just check that out. There we go.
And if you go to examples, very top.
Nice. Problem slice.
And events to frames.
Nice.
So this works, and this converts. At the moment, there's no video support yet, so I can't export to MP4. It exports to a bunch of PNG images. And whilst it might be tempting to write a single function that just says render, takes the events, turns them into frames, there are actually quite a few steps that I think are mandatory anyway. So when you're converting, you will need to go through those steps. And I think that showing them is interesting because there are interesting things you can do in between those different layers. So to me, there's sort of a pedagogical dimension as well of showing people what exactly is involved in converting events to frames and why it's complicated and why there's actually quite a lot of flexibility in how you can do that.
Yeah.
So from a Python API perspective, that was kind of the idea of, instead of having one big function with a million arguments, to kind of have a bunch of simpler functions that convert between stream types and show the user kind of the internal machinery, the different steps, as well as giving them something that works. The downside is that from the command line, you don't necessarily care about any of this.
Well, I mean, okay, so first of all, I mean, just be careful all this, right? We can totally simplify this in the command line, right? So something like render would then do this all at once, right? But also, I think that I see slightly different. I wonder whether I see slightly different functionalities in terms of converting streams versus handing outputs, but I don't know. It's just I'm thinking about it more in general, like, because if you have a stream of sorts, right, then I think there's a lot of different, like, let's just call this stream. There's a lot of difference between being able to do this, and so on, and doing this. Right. And I think one of the original discussions we had would be something like this, because then you would have distinguish between morphing a stream, so basically changing its behavior somehow, but it's still a stream, and then consuming the stream, so like completely eating up the stream. I'm not sure that's helpful, because here I think it's much more functional.
Yeah, so the convention that I've followed so far is that any function that starts with _2 means that you're consuming the stream, converting it to something else, to files, to arrays, etc.
To frames, right?
So that's why I avoided this particular phrasing.
I see. Yeah.
To make it clear that 2 frames isn't something that consumes; it's really just conversion to another type of stream, but you're still dealing with the stream.
I like it. Yeah.
Hence the term envelope, because I couldn't find a better verb for it, but I'm happy to change it. It's really the idea of taking a time surface or binning, but really it's not exactly binning, because we're really just taking the last event per pixel.
It's
and
decaying,
to me, that is
right,
kind of the envelope of the 3D point cloud at that point in time. It's the surface alongside the time axis, which is why I guess people call it a time surface, but it's kind of weird as well. Or a context, maybe. But context isn't really a verb. I really like the idea that everything should be a verb. Because those are actions.
Yeah.
Hence the term to envelope, which is weird. Framify, or you can call it Framify.
But I think that's I mean, I think this is fine for now. Especially what I like is convention, right? So we can just say anything that is 2 consumes, and then we can deal with that later. But then that does remove the luxury of having objects, right? So no longer, we can't just say, there's no output now, right? And then say file config, right?
I see what you mean.
Which is also fine. I don't think it matters necessarily, right?
Yeah, it's kind of, I find it more functional in that it's just a way to bundle your options, right? If you were to write 2 outputs and your output was and an object that defines what the output is, That's almost just a way to bundle the parameters of the function. Unless you're
totally.
inheriting from that output object, you customize the behavior.
Well,
but for that,
I think it's more of
Go
a,
ahead.
like, for me, it's more of a distinction between like a functional approach where you'd have like mapping and filtering essentially, versus this is more like this is actually like this is more like of a procedural approach, right? Because you just stepwise go through. But I mean, I think this is totally fine. Let's just keep it as it is for now. I just wanted to
Okay.
relate this to the CLI, because that means if you want this to match, like you said, then we indeed need to do the object inspection, right? Because there is no configuration. We would have to check. Okay, if you ask for virtualized filter, does that exist in the stream object? And if it does, then call it, right, with these different parameters,
Yeah.
which is totally
So
totally doable.
I think that a big benefit of this approach is that you can encode in the function name the outputs. So envelope, for instance, is a function that exists on event streams, but it returns a frame stream. If you go with something like apply,
that is a really
you
really
need more
good point.
generic streams.
Yeah, because here you really have the type with you. That is an excellent point, because Python would not be able to support that. And that relates to the type discussion we had last time around, right?
So you could with @override using typing files, but it quickly gets out of hand.
Yeah, I agree. Okay, amazing. But back then to the rendering situation, right?
Yes. So one option is to say, actually, the internal machinery is pretty and everything, but really making it easy for users should be the priority. So if that's the case, we should definitely have a bigger render function. It could live alongside the existing filters. That is a shorthand for all those filters in one big block.
Yeah.
And that render function would then be part of the functions naturally available to users. And that kind of solves our conundrum here, because we can make it very IO-centric. It's pretty easy. You just write Faery input, output, and in the middle there's just one filter called render. It's not insanely complicated. Or we decide that we want that render filter to only exist in the command line bubble. It's actually hidden from the Python API. It's something that's only available from the command line interface.
Yeah.
And the last option is to not add anything at all, and let users just copy-paste a massive command when they want to render.
I like the approach of having it in Python, and I also like the simplicity of things. Like so I think it's great to optimize and compress things. I think to begin with, we should just do whatever is easy. So I mean, if you don't mind, I think I prefer to start with the IO-centric 2 approach. Like just to see if we can add this render filter, but and then just see how it can be made more. Maybe also get a feel for what we would like to do. You know what I mean? Like, so as we work with it more, we probably understand what it should look like.
The CLI that I implemented is essentially IO-centric 2. With one big difference at the moment, which is that since I wanted those other shorthands, it has an extra action to tap into one of the subparsers of outparse. So at the moment, instead of writing Faery and you can immediately start putting together input and outputs and filters and so on, you first specify what part of the CLI you want. So you use Faery render or Faery inline. Inline is a bad word for it, but really Faery IO pipeline, if you will, and so on, and then everything else. So the question is, do we keep that? And that gives us a bit more flexibility to implement other functionalities. For instance, if you type in Faery color maps, it should generate an image of all the color maps currently built into Faery.
But why is that? That doesn't have to be mutually exclusive. I mean, you could have this, right, by default. But then if you write this as a subcommand, then that's what
I see what you mean.
you defer to. So essentially, this could be shorthand for something. But again, I mean, I wonder whether it makes sense to begin with something which is consistent, right? Something like we say we have an input, we have an output, and then maybe later when we want to optimize things, we can try to make it more clever and maybe compress some of these commands in a simpler.
I like
shape.
that. So there is one challenge, which is that if I'm writing, say, Faery init to use the last feature I mentioned, or the iterating through a directory, then the parser needs to figure out whether init is the name of the first filter that the user wants to apply to an input-output pipeline, or whether they're trying to use a different part of the CLI.
Well, if filter is already always prepended by a exclamation mark, for instance.
Oh, that is true. So then you...
or that would at least be the point here, right? Because you cannot have an input unless you specify, now I'm giving you an input. So it's very verbose, but it's extremely disambiguous because it will always parse this, essentially. There will be no disambiguity.
So if it doesn't see an exclamation mark, then it tries to find the keyword.
Yeah, if you just write, so for instance, if you just write Faery render, for instance, right? It would I don't know what render is unless we specify it. If you then write exclamation mark render, then you're specifying the render filter. I don't know if that makes sense.
It does. But the alternative to that.
Yeah, I'm happy to talk about other things. This doesn't have to be the end all be all.
Yeah. Right? Would be to make the first exclamation mark optional, because really they're meant to separate filters, really pipe in rather than, though arguably you should pipe into the first filter anyway. And to add a special keyword when we want to use Faery's command line, specifically to build a pipeline. So it could be Faery pipeline. That tends to be a little easier because that way we can use ArcParse's built-in ability to separate those different things.
But how?
But we don't have to.
I mean, isn't that exactly a problem? Because if you don't have exclamation mark or clear delimiter whenever you have a filter, you have to then case match. Right, because
yes,
I guess
that works.
Sorry, go ahead.
So that works fairly well in that this goes straight into this nargs catch-all, at least if we're using ArcParse. I'm very much looking at it from the lens of ArcParse here. But basically, you can think of you getting a string of everything that was passed besides the options. And then it's pretty easy to enforce a rule where instead of searching for all the exclamation marks, you just split on the exclamation marks. And then you pass individually each block resulting from that, which makes the first one optional.
But then there can still be ambiguities here, right? So my point is you wouldn't know where to start that split.
I see what you mean. Yes, especially if the file has a bunch of options.
For instance.
But because the file is optional, so then again, unless we don't use ArcParse, which might be a good way to work around this particular problem, ArcParse was essentially take away from us the dash input with the fact that there's a file that's taken out and that's placed in a different bucket. Which means that from the perspective of the sub-parser is going to be in charge of building the pipeline, x.a.4 would show up as a completely distinct parameter.
It could in principle. By the way, I also want to correct myself. I think I said before that argparse can't do recursive parsing. I think it actually can. That was a mistake to some extent. But Peter, also by the way, we actually did look into Click, and I used that in a previous version of the API. I think the challenge there is that that's an external dependency, which, yeah, I don't know. But that actually gives you exactly this. The problem is you can't have sub commands, because this is essentially a sub command, and this would be a sub command to the sub command in terms of file.
That is true. Okay, so if we take away, remove the implementation for the time being and think of it in terms of
that's probably
overall
a good idea. Yeah.
API, think that we're looking at different use cases that would almost mandate different commands. That's how GStreamer does it. So GStreamer, the project, has, when you install it, actually comes with different commands. So the one that I mentioned to create pipelines is called GST launch, but you also have GST inspect to get a list of all available filters, and GST is something else. So basically the project in and of itself has different commands.
That's interesting. Yeah.
More modern parsers, I don't know if you've had the displeasure of dealing with Azure and the whole Microsoft cloud infrastructure.
Luckily not.
Lucky man. So they fortunately have a relatively nice command line interface for their thing called AZ, which is fairly short. It covers everything from creating new virtual machines, accessing the logs of the virtual machines, creating new IP addresses, and so on and so forth.
Cool.
And for that, they use subcommands, essentially. So you've got AZ Docker, and that's all the things, or AZ Kubernetes, and that's all the stuff that go to Kubernetes and so on. So that's kind of why I feel like we should either have multiple commands, not necessarily a bad thing. So you've got Faery, and then there's also Faery minus something, like it's a different command for the more niche cases.
Yeah.
Or if we want to encourage discovery of those different ways of using the library, we bundle everything into one namespace, Faery, but Faery is always followed by an extra keyword. And that keyword indicates what part of the CLI.
In principle, I hear you, and I think that's not a bad idea. I wonder if we can carve out like something that covers most of this, not necessarily everything, but most of this, which we can get going on some implementation, because I think that'll also help us understand what are then the use cases, so that we later down the line can define. And then I think you're right. We could and probably should define additional subcommands to then solve edge cases, right? If you want to clarify it, specify it further.
But what you're saying is that for the time being, you'd rather avoid subcommands and have just one interface.
Unless the absolutely need. My thinking is like I want simplicity. I want something which is simple to do right now, and it might not be super pretty, but I think aesthetics is my secondary concern essentially, because I think you're right. We might want to compress some of these things. I don't know. I just don't have an overview of what. Let me put it that way.
Yeah. I'm pretty sure that we can fairly easily build something that is always clearly one thing or another. So say whether there's an exclamation mark or not. I just at times find it slightly easier to generate good error messages with an ever so slightly more verbose option. So you're forced to write a specific keyword to mention what you want to do, and that lets us write better messages rather than I do not know what time is. Instead, we can say the time filter does not exist. Here's a list of the filters.
Yeah, I like that.
Which would only make sense if you've entered the building a pipeline from the command line subcommands.
So you're speaking for something like this, essentially, the way we're very verbose to begin with.
Yes, pretty much. But with an extra keyword in front of all of this. So essentially IOcentric 2 or IOcentric 3, where just after Faery, there's an extra keyword that says something like pipeline, or whatever you want to call this particular thing. And that means I want to use Faery to build a command line pipeline. It could be the input could be a file, it could be standard input. Both are supported, but I'm building a pipeline. And that lets us have other keywords like color maps, which shows you a list of available color maps for rendering, or
so I hear that.
in
I
it.
just
that sort of stuff.
But wouldn't that be possible then to have, let's say, we have this as a default option, for instance. So the default would be this, but then, for instance, if you want color maps, then you do something like this. Right, so the default command would be this, but then later if we want to add other subcommands or other behavior which is specific, like it could be color maps or even render, which would be kind of a how do you say, like a specialization or a compression or a simplification for some of the users, we could then simplify that with additional commands. So this would be kind of the default. I mean, we can also do the opposite, right? So that there is another default. It just like what I really love about CLI tools. That may be just my own personal oddity here. What I love is I can take it, I can just run it, and it gives me a meaningful behavior. Right? I don't need to study much. I can just have it run. Because this, in principle, like having Faery running here would then be by default just streaming or mapping from A to B essentially. But we can also define a different default. Maybe Faery is more known or should be more relevant for presenting color maps or something like this. I just like having a Faery command.
I see what you mean.
But would you agree with that, or
okay.
Because we can also,
no.
I mean,
I'm very happy with this behavior.
And I mean, and a counter argument to that would be that we want to be extremely verbose. We want to be very specific in what you can do. So we can also postpone the default essentially, and just start by working with something like this.
I do like the complete default sort of thing. I tend to work differently when I'm using complicated command line tools. I usually find something to copy paste from the internet, if I'm being honest. Which is probably not the right way to do it. So if we build a tool where someone could just, without any prior knowledge, just type Faery, and then the next steps are suggested as an answer to that prompt, and it sort of feels natural to quickly build a filtering pipeline, that would be absolutely amazing. So very keen to try the IO-centric 2, like sort of the absolute default where there's no extra keyword.
Okay, yeah, it's like this.
Yeah, so the default is that without the pipeline, and then we have extra commands for color maps and to support the last use case, which is generating a template script.
Yeah.
Which would be Faery init or Faery template or Faery scan, because you're typically scanning a directory when using that, but we can work that out later.
Yeah.
So, okay. I like this interface. So now I'm thinking of the implementation.
Yes.
So one challenge, as I mentioned with argparse, is that argparse would take out -- input and the name of the file and take that away.
Yeah.
And also, basically, we would need to define the flags on Faery, the main body of the command, which means that all the flags would be, at least as far as argparse is concerned, available in all the other modes as well.
That sucks.
In turn, we would need to do some backpedaling in those modes to say, well, you specified inputs with color maps, but because color maps, you've entered the color maps subparser, and that one does not have -- input as an option, so we have to raise custom errors. So this is a bit harder with argparse. but we can either roll everything ourselves. So we just consume the entire command line as one big string. And we just do all the parsing with our own rules. Not all that difficult to do, just a bit harder to maintain.
And I think hard to get good error messages as well, right? But
or we use another parser. So if you look at the chunk of code that I wrote for the parsing, it's already a massive mess because I added custom errors. I wanted to add like the little waves and the cursor that tells you where it is. And I'm pretty sure that there are also edge cases where this would break spectacularly. But yeah, it is difficult and only partly debugged. So I'm pretty sure that there's a fair bit of work involved in doing that. The alternative would be to find something else that lets us implement exactly what we have in mind, but that might come with other drawbacks in terms of adding more dependencies and perhaps having its own idiosyncrasies.
I did like Click just for quick iteration, right? I know it's not optimal to have dependencies, but it's a very minimal library. They don't have other dependencies.
Just the one on something for Windows to support colors in Windows.
Oh, that is correct. That's correct.
But I think that's only a transient dependency if you're on Windows. So not that big a deal, but if it doesn't support the custom pipeline specification either, we would still need to roll out most of it ourselves anyway.
How about the following? Because I do have to run. I have a next meeting in 3 minutes. Like, I'm happy to give it a stab just to see if I can get something which is easy and minimal, and see where we can go.
Absolutely. Do have a look at what I wrote. I know that it's a bit of a mess, but you might be able to use some of those or the parsing.
A lot of the ideas are very good.
Please feel free to iterate, and I'm sure that as you're working on it, you'll find edge cases we haven't thought of. So feel free to kind of redirect it. And I think that you're a more likely command line user than myself. So do go with your gut.
I think we just have to find something that we can get running easily, right? Part of the exercise also for me is to get ownership over the code, so I know what's happening. And I worry like very complicated things will make it difficult to engage with, right? We want to iterate quickly as well.
It is absolutely true. So what I might do in the coming days is focus on the video generation part of it, which is fairly orthogonal to any of this. Plans just to have baked in Rust MP4 generator that we can generate videos without depending on FFmpeg, which is great unless you're on Windows where it's a mess to install.
But I like that a lot, especially because, like you say, it's just quote unquote a feature, right? And I have also been talking to, I think I mentioned this to you as well, but I have been talking to a guy where we can consider doing some WGPU implementations for the GPU.
Oh, lovely.
The GPU frame generation, ideally so it supports DLPAC, because then we can just use Faery for all the different machine learning libraries, which also I think should be relevant for Tonic, right? Because ideally we could do some interesting data processing in the Tonic context as well.
Absolutely.
Cool. I'll stop recording.
Awesome.
Thank you for today. This has been amazing.